Okay, let's see what range of values does entropy lies between. Before looking into the values, let's understand what an entropy is. Entropy usually refers to the impurity. It is also known as the measure of impurity. Entropy is defined as negative of sigma ranging from I is equal to 1 to k, where k refers to the number of classes in the classification setting. It includes probability of I multiplied with log of probability of I base 2. In order to understand it more and define the range of values, let's see two cases. I'm considering one as the best case and other as the worst case. In the best case settings, I'm assuming a pure node. So whenever we say a pure node, it means that all the samples in the node either belongs to a positive class or to a negative class. In this example, I am taking that all of my 120 samples are belonging to the positive class. Similarly, in the worst case, I'm considering a impure node. So in the impure node, the probability for all the classes will be equal. That is, if you see here, the number of samples in the positive class are 60 and the number of points in the negative class are also 60. So this is the best case scenario I'm considering, and this is the worst case scenario I'm considering. Now let's try to compute the impurity or the entropy in both of these cases. First, I'll try to compute the impurity for the pure node. So for the pure node, first it is like negative of, first for the positive sample, I'll compute it as 120 is the probability, like 120 by total number of samples, positives by positives plus negatives into log of 120 by 120. Plus, in the negative setting, it is 0 negatives by positive plus negatives into log of 0 by 120. So if you work this out, we'll get the value 0 as entropy. And also, if you see here, if the entropy value is more, that refers to more impurity. If the entropy value is less, that refers to less impurity. In this case, we got the entropy or impurity value is 0 because it is a pure node. That's obvious. Similarly, let's compute the entropy for the impure node. So same, it's like negative of, first I'll take the positive points, that is 60 by total number of points 120 into log of 60 by 120. So I'll add for the negative setting, again we have the same 60 by 120 into log of 60 by 120. So if you work this out, here we'll get the value as 1. Okay, because it is a completely impure node. So you'll get the maximum value. If you work this out, you'll get 1. So from this best and worst cases, we can see that the entropy lies between 0 and 1. So here, let's draw the graph for it. So let's say the entropy lies between 0 and 1. So in which cases it will become 0? Either if all the points belongs to the positive class, that is in this extreme, or if all the points belongs to a negative class, that is this extreme. In both of these cases, the entropy is 0. And in the worst case, the impurity is 1. That is at 0.5. That is probability of a point belongs to a positive class. So when it is 0.5, the entropy will be maximum. That is at this peak. So, and if we try to compute for 0.2, 0.3, 0.7, we'll see the curve something like some smooth curve like this. So the entropy is lies between 0 to 1. The entropy will be 0 for the best cases, for the pure nodes, and the entropy will be 1 for the impure nodes. And again, as a follow-up question, do you think the entropy always lies between 0 and 1? So there are some small exceptions. For example, instead of dealing with the binary class setting, if you consider, let's say, a multi-class setting, let's say a 3-class classification, in that case, if you use the same formula with log base 2, then there will be some cases where you will see the entropy greater than 1. Okay. But that is still okay. In most of the implementations, people will only use base 2, which is okay. Even if entropy is greater than 1, still that refers to the impurity. But if you specifically want your entropy to always lies between 0 and 1, then what you can do is that you just try to keep this base as k. Okay. So instead of keeping the base as 2, you define the base as number of classes that your problem have. Okay. Thank you.